Welcome to an introduction on factoring perfect square trinomials. So just to start off our lesson, we're going to recall what a perfect square trinomial is by expanding before we factor. Expanding is always an easier thing. We've learned that first. So let's expand a plus b all squared. Now, this is going to be a plus b. If you're squaring something, that means you're multiplying by itself twice. And if I were to multiply that out, a times a would be a squared. A times b times and another a times b will give us 2ab's. It gets doubled, that middle term. And then b times b will be b squared. If we do a minus b all squared, that means a minus b is written out twice. And again, if we expand that or FOIL that, a times a would be a squared. A times negative b will be minus ab. And negative b times a will be also another minus ab. So minus ab minus another ab will give us minus 2ab. And negative b times negative b will be plus b squared. Okay, so for each of these are examples of perfect square trinomials, which is the point of today's lesson. So for it to be a perfect square trinomial, the things we're looking for are the first and last term are perfect squares. First and last term are perfect squares. And then, let's get a thicker pen here. The middle term has to be double the square root of the outside terms. Okay? So that middle term, second term, is double the square root of outer terms. Okay, so let's factor this fully. Let's see if this is a perfect square trinomial. Take a look here. It says the first and last term are perfect squares. So let's take a look here. Is this a perfect square? Yes, it is. X times x is the square root of that. Is this 16 a perfect square? Yes, 4 and 4 is the square root of that. So the other thing we have to double check, sorry, I keep jumping here. The second term is what we also have to check. Is that double the square root of the outside terms? So let's square root this. The square root of that is going to be 4. Square root of this is going to be x. And let's multiply this. So 4x. And let's double it, which is this part. So if we multiply 4x and double it, that gives us 8x. It is now double the square root of the outer terms. Okay? So this is indeed a perfect square trinomial. Okay? It's a very important skill to be able to identify a perfect square trinomial. Okay, so PST stands for perfect square trinomial, and that's what we're going to do here. So now that it's a perfect square trinomial, we can factor this a little bit using a shortcut. We take the square root of this, which is going to be x and x, put them both here because x times x gives us x squared. Take the square root of 16, which is going to be 4 and 4. And this is positive 8x, so it has to be double, and these are both going to be positive. So let's take a look at, let's take a look at this and double the product of x and 4, and that will give me 8x. Okay, and so I know I've factored this fully. Over here, let's take a look. Is the first and last term, are those perfect squares? Does that satisfy that first condition there? Yes, 9 is a perfect square. A squared is a perfect square. 4 is a perfect square. Positive 4 is a perfect square. And b squared is a perfect square. Okay, I'm just going to go back here for a sec. It's important for it to be positive because if it was negative, there's no two numbers that could multiply to negative 4. Negative 4 is not a perfect square, but plus 4 is indeed a perfect square. So let's write that down. It must be positive. It's a very important point. Okay. So now we have to check out the second condition of a perfect square trinomial is if we take the square root of the outside term. So what's the square root of 9a squared? That's going to be 3a. The square root of 4b will be, square root of 4 will be 2, square root of b squared will be b. And we have 3a and 2b. Let's multiply them together. 3a times 2b was 6ab. If we double that, it's going to be 12ab, which matches this. So yes, it is a PST, a perfect square trinomial. Good news. As a result, we can just factor it by, let me get a thicker pen first, by putting the square root of 9a squared here, which is 3a. I'm going to put 3a here, 3a and 3a. So 3a times 3a gives us 9a squared. And the square root of 4b squared is going to be 2b and 2b. And that gives us 4b squared. And we know this is going to be a negative, so they're going to have to both be negative. And you can check by doing this part of the foiling, the outside and the insides. Negative 6ab and another negative 6ab gives us negative 12ab. So we factored that. Let's take a look at this one. They're asking the question number 2 is asking us if x squared plus 10x plus 16 is a perfect square trinomial. Well, let's take a look at this part. That's a perfect square. This is a perfect square. Now let's see if the middle term is satisfied. If the middle term satisfies the condition of a perfect square trinomial, we take the square root of the first term, which is x, take the square root of the last term, which is 16, multiply them together, which is going to be 4x, and then double it, which should be 8x. So they have 10x. We need 8x for it to be a perfect square trinomial. So this is not a perfect square trinomial, okay, because it's not double the square root of the outside terms. Nope. Okay, the middle term I'm going to type this is so nope. The middle term is not double the product. I think I've been missing this part of the definition. It's not double the product of the square root of the first and last terms. Okay, that's why it's not a perfect square trinomial. Okay, let's do part number 3 here. Determine the value of k such that x squared plus kx plus 121 is a perfect square trinomial. So we get to design a value for k. We get to choose a value for k to make it a perfect square trinomial. Okay, so again, look at the definition of a perfect square trinomial. Are the first and last terms perfect squares? Yes. The square root of x squared will just be x. The square root of 121 is 11. Okay. And now this middle term has to be double the product of the outside terms. So the product of these two will be 11x. And then we have to double that. So if we double the product of the outside terms, that's going to give us 22x. So for this to be a perfect square trinomial, k will have to be 22x. Okay, and that's it for a perfect square trinomial. Make sure you always apply these 2 parts of the definitions, and you'll be fine. Okay? Good luck, and if you have any questions, please contact me on Google Chat or email me.